Hi everyone! In this video, we're going to continue talking about strategies for factoring, and specifically we're going to look at those three different strategies for factoring our trinomials. And so the process that I'm going to follow as I'm thinking through these problems is going to be referring back to the flowchart that was seen in the factoring strategies video or worksheet, so you can reference those. The first example that we're going to look at is how we might have to use this process more than once to get prime factors. And so the first thing we're going to do is we're going to look at our expression 8x cubed minus 8. And so the very first question that was in that flowchart is, do our terms have a common factor? And in this case, I can tell right away that 8x cubed and negative 8 are both divisible by 8. So we can actually rewrite this. So I'm going to say, yes, they do have a common factor, and that's 8. And so when I rewrite this, we're now going to get 8x cubed minus 8 is equal to 8 times, well, 8 times what gets us x cubed? That's going to be x cubed. And then 8 times what gets us negative 8, and that's going to be a negative 1. So now we have successfully factored out our greatest common factor of our two terms. So now we ask, okay, we have two factors, 8 and x cubed minus 1. Can these factors be factored anymore? Or do we have prime factors? Well, the concern that I have here is we have an x cubed in our factor that is in parentheses. And so if I looked at that flowchart and I saw that we have two terms in our polynomial factor, and we have three possibilities to consider. So first off, is it a difference of squares? And so again, we're just considering this x cubed minus 1. And we cannot have a difference of squares. And the reason is because our x is cubed. So that automatically discounts that we cannot have squares. Our next question that we ask ourselves is it a sum of two cubes? Which is possible, right? Because we have x being raised to the third power, but we have a minus sign. So it's not a sum because we're subtracting our two terms. So this can't be either. And this is because we're subtracting. So then our last question that we can consider here is it a difference of two cubes? And in this case, it actually is. And so I'll show you how we can rewrite this in terms of something cubed. So we have that 8 out front, that greatest common factor we had taken out. And then we have our x cubed and minus 1. All right, so rewriting this first term, x cubed, is x and it's being cubed. We have a difference. And then the cube of 1, so we have 1 times 1 times 1 is itself 1. So 1 is the cube. So there I've just rewritten my factor in terms of our A's and B's, just like we had in that formula in that previous worksheet with factoring strategies. So I'm going to use and apply that formula. And when I do, we end up getting, and again, we're just applying this to the inside, our brackets. So we're going to have the difference of A and B, so x minus 1, times x squared plus x times 1 plus 1 squared. And so then we can carry out this multiplication. So we end up getting 8 times x minus 1 times x squared. X times 1 is 1x, and 1 squared is 1. So now we have factored our one factor of x cubed minus 1 into two separate factors that are x minus 1, and then x squared plus 1x plus 1. So now we have to ask ourselves again, we have these new factors. Can these be factored anymore? And in this case, I'm really concerned about x squared plus 1x plus 1, because this is a 2-degree or second-degree polynomial that we have as a factor. And remember, a first-degree factor cannot be factored into any smaller degree polynomials. So that one is as factored as it can be. So we're done with that one. But if I think about this factor x squared plus x plus 1, it's not a square of a sum, and it's not a square of a difference. And those were two possibilities we could have. So now, since it's neither of those, we can look at all possible combinations, and we can look at this with trial and error. Now, we haven't gone over trial and error quite yet, and I'll be looking at that exclusively in this next example. But let me talk through this using that method. So if we're looking for numbers that have a product of 1, because that's our constant here, so they have to multiply to be 1. So the only factors we can have is 1 and 1. And then we could have -1 and -1. Let me make this a little clearer. Now, if we also have to have that the sum of our factors is equal to the coefficient of x, which is 1. But if I add 1 and 1, I get 2. And if I add -1 and -1, I get -2. So neither one of these is going to satisfy both of those things at the same time. They're not going to be both a product that gets us 1 and a sum that gets us 1. So because of that, we're done. There are no other possible ways for us to factor out that x squared plus x plus 1 factor. So therefore, we have as our final answer that 8x cubed minus 8 is equal to 8 times the quantity x minus 1 times the quantity x squared plus x plus 1. We have completely factored our polynomial. All right, so now let's go ahead and take a look at how we can apply this trial and error method. And so here we're given a different polynomial. We have x squared plus 5x plus 6. First, you'll notice that there is no greatest common factor. There's not something that evenly divides x squared, positive 5x, and positive 6. So we don't need to do that. And we first now move on to how many terms does our polynomial have? And there are 3 things being added together, so there are 3 terms. And if you go down the list, there's actually no formula we can use. And so now we have to do the list all possible combinations option. And so to do so, we're going to use trial and error. So the first thing that we need to recognize is that this is a second-degree polynomial. And because of that, we cannot have any more than 2 prime factors. So as high as the degree is, so if this was a third-degree polynomial, we could have no more than 3 prime factors. So that degree helps us determine how many maximum factors we can have. So the first thing we're asked to do is find the first 2 terms in the parentheses. And so what I mean by that is we have to somehow get an x squared term for our polynomial. And the only thing that multiplies to be x squared is an x times x. So we've now found the first term in both sets of our parentheses. Then the next step, it asks us to find the last terms in the parentheses. So we're looking for what goes here. And so in order to do so, we need to have that these 2 terms multiply out to be our constant, to equal 6. So 6 is the product. Of, and then I'm going to call these n and m. They're just placeholders for numbers that we're looking for. So if we're trying to find two numbers that multiply to be 6, we're going to write all the possible factors of 6. So we could have 1 times 6. We could get 2 times 3. And then remember that a negative times a negative also yields a positive product. So -1 and -6 are possibilities, as well as -2 and -3. Now, in the next step, it says to try different combinations of these factors. So these factors that we found for our constant of +6. And so what it means by different combinations is we're going to plug in these numbers for n and m respectively. So we have x plus 1 times x plus 6, or we could have x plus 2 and x plus 3, or we could have x minus 1 and x minus 6, or x minus 2 and x minus 3. So now we need to find that when we have the outer and inner products and we add them together, we should get our middle term of +5x. That is what we're hoping to get. So let's go ahead and first we're going to multiply, find those outer and inner products, and then we'll add them together. So the outer product of this first possibility is x times 6, which is 6x, and 1 times x, which is a +1x. Adding 6 and 1x together, we get 7x. The next one, our outer product is x times 3, which is 3x. Our inner product is 2 times x, which is +2x. Adding those together, we get 5x. Next, we have x times -6, which is a -6x. -1 times x, which is a -1x. Adding those two together, we get a -7x. And then x times -3, we get -3x. -2 times x, we get -2x. Adding these together, we get -5x. So you'll see that there is only one possibility that gets us a sum of 5x, and that is when our factors are x plus 2 and x plus 3. So we have found our factors. So I can rewrite this as x squared plus 5x plus 6 equals x plus 2 times x plus 3. And remember, as we had talked about previously in a video, if you're unsure or want to check if your factorization is correct, then you need to distribute and multiply those two factors together and see, do we get the original polynomial back? And we will. So if you'd like to, feel free and check our work using the distribution property. One thing I want to mention here is that this method can be more difficult and time-consuming if our leading coefficient is greater than 1. So in this case, our leading coefficient, so that coefficient with our x squared term, is 1, and that makes our life really simple when it comes to using trial and error because there's fewer things that we have to take into account. We only had to list the factors for 6 in this step 2. But it gets a little more complicated as that leading term increases or decreases. So I'll show you some alternate methods that you could use that help you organize your work in a way that allows you to incorporate what that leading coefficient does to the rest of our problem. So let's explore.